Welcome to EDU World Space.
Hello and welcome to Chapter 1, Problem number 43 in Physics for Scientists and Engineers with Modern Physics. So this problem tells us a little bit about the growth of a lamb pet. And this is going to be a relatively variable, dense, and very vague problem until we get to our final answer here where we plug our numbers in. So we're going to say let L and M equal our initial length and mass, and L prime and M prime equal our final length and mass. So what we need to do first is dissect this word problem and convert what it says in text into mathematical equations. So we start that by looking at our length. It tells us that our length is increased by 15.8%. So a way of writing that mathematically is saying L prime, that final length, is equal to our initial length times 1 plus 1.158. We convert that percentage into a decimal and then add 100 to it, multiply that quantity by L, and that'll give us that final length. So L prime is equal to L times 1.158. And something similar for our mass, it tells us we have a 17.3 kilogram increase. So we have the final mass minus the initial mass is 17.3. And in this problem, we're actually going to solve for our M, not our M prime. And we'll get to that later on in the actual problem. But either way, we have M is equal to M prime minus 17.3. And so pretty much we're relatively done with this problem in terms of the mathematical descriptions. We need to look back at the original, the first sentence here. That tells us that our mass is proportional to our length cubed, and so I have that here on with these two equations. We have our original mass is equal to some whatever constant k. This is more of a volume constant, just to verify that it's not just equal to the length cubed. But these two constants k here and k here really don't matter. But it's just a mathematical way of saying, there's some discrepancy here. But what the whole point of all this is saying that we can make a proportion with m's and our l's. We have m over m prime is equal to l cubed over l prime cubed. And that's basically what all I was trying to get at with that first sentence there. We have our masses being proportional to the length cubed. And we can write this equation here, which is very true. We don't need to really incorporate k in here because it's a constant and they'll come out. So what we need to do next is plug in values, the values that we started with up here, underlined in blue, L prime and M neutral. So we do just that. We plug them into this equation here. So we'll have M prime minus 17.3 over M prime is equal to L cubed over the quantity of L cubed times 1.58 cubed as well. So at this point, we need to cancel our L cubeds, and we break up this fraction here into two different fractions, right? Because if we have binomial or trinomial or whatever in our numerator, we can break that up into different fractions themselves. So we'll have m prime over m prime minus 17.3 over m prime. And so that first fraction will give us 1 minus 17.3 over m prime. And then we cancel the L cubes. So we'll have 1 over 1.58 cubed. So up next, it's just pretty much algebra at this point. We bring our 1 over, we subtract the 1 over, and then I'm going to also divide or multiply by -1 as well to get this negative out of here. So we do I'm jumping a little bit of steps, but I hope you'll follow with me. So we'll have 17.3 over m prime is equal to negative 1 over 1.158 cubed plus 1, right? We subtract the 1 and then multiply by -1. So that gives us positive 1. Another way of saying this equation is 1 minus 1 over 1.158 cubed. At this point, we can pretty much solve for m. We have m prime is equal to 17.3 divided by the quantity of 1 minus 1 over 1.58 cubed. And when we plug all of our numbers in, we're going to have a final mass, M prime, of 48.6 kilograms.